A'udhu billahi minash shaitanir rajim. Bismillahir Rahmanir Rahim. Assalamu alaikum students. Today we are starting chapter number 2, Vectors and Equilibrium. Vectors. At a school level, we have studied that there are some physical quantities which require both magnitude and direction for their complete description, such as velocity, acceleration and force. They are called vectors. Usually, vectors are denoted by bold-face characters such as A, D, R and V, while in handwriting we put an arrowhead over letter, for example D bar. If we wish to refer only to the magnitude of a vector D, we use light face type such as D. Now representation. A vector is represented graphically by a directed line segment according to a chosen scale, corresponds to the magnitude of the vector. In this chapter, vector is symbolically represented by capital A bar, B bar, C bar or small a bar, B bar, C bar. The magnitude of a vector can be represented by a simple face letter as A or magnitude of A bar. Read as A modulus. Symbolically, the direction of a vector is represented as A cap. Read as A cap. As a vector has a magnitude and a direction, therefore symbolically we can express it as A bar is equal to mod of A into A cap. This is equation number 1. Graphically, a vector is represented by an arrow which is drawn according to a scale. The length of the arrow gives the magnitude of the vector quantity under the selected scale, and the arrowhead indicates the direction of the vector. For example, a student travelled 100 meters from a school towards east. Graphically, it can be represented as let 1 centimeter represents 10 meters. The starting point is usually called origin or tail of a vector. The end point is usually called head of the vector as shown in the figure. The direction north, south, west and east are also shown in this figure. Now vector representation, Cartesian coordinate system or rectangular coordinate system. For the graphical representation of vectors, beside north-south and east-west direction, the concept of up-down and right-left can also be used. But for the sake of simplicity and uniformity, a set of two mutually perpendicular lines for the two-dimensional cases are used as shown in the figure. These are called coordinate axes and their point of intersection is known as origin. This system of coordinate axes is called Cartesian or rectangular coordinate system. One line is named as x-axis and the other is y-axis. Usually the x-axis is taken as the horizontal axis with a positive direction to the right and y-axis as the vertical axis with the positive direction upward. The direction of a vector in xy plane is denoted by the angle which the representative line of the vector makes with positive x-axis in anti-clockwise direction as shown in the figure. The point P shown in the figure has coordinates xy. It means that we can reach point P by moving A bar units along with positive x-axis and B bar units along with positive y-axis. To describe the direction of a vector in a space that is 3D, means 3 dimension, another axis is required along with x and y axes. The third axis is usually called z-axis and is perpendicular to x and y axes. Three mutually perpendicular lines for three-dimensional cases as in the figure shown. These lines are usually named as x-axis, y-axis and z-axis as shown in the figure. For two-dimensional cases, that is when a vector lies in a plane, only one angle, either alpha, angle with respect to x-axis, or beta, angle with respect to y-axis, must be known to describe the exact direction as shown. Similarly, if a vector lies in a space that is in three-dimensional system, then its direction can only be determined if its angles with respect to x-axis, that is alpha, with respect to y-axis, that is beta, as well as with respect to z-axis, that is gamma, are known as shown in the figure. Now, addition of vectors. Vectors can be added by two different approaches, namely graphical or geometrical method and analytical method. Graphical or geometrical method for addition of vectors. In this method, vectors are added by sketching scaled diagrams. For graphical approach of addition of vectors, we use head to tail rule. Following steps must be followed to add vectors by head to tail rule. Number 1. Select a suitable scale for the representation of given vectors. Number 2. Sketch all the vectors according to the selected scale in its given direction. Number 3. Now join the tail of the next vector to the head of the recently sketched vector and draw its representative line according to the selected scale in the given direction. Number 4. To find resultant, join the tail of the first vector to the head of the last vector and put an arrow on this line pointing away from the origin. Label this vector as r bar, means resultant vector. Resultant vector is a single vector which has effect equal to the combined effect of the given vectors. Number 5. To determine the magnitude of r bar, measure the length of r and convert it according to selected scale. Number 6. To determine the direction of r, measure the angle of r with respect to positive x direction in anti-clockwise sense. Example 2.1. If two forces F1 and F2 as shown in the figure are acting on a block, find the magnitude as well as direction of their resultant. Now we will follow the above mentioned steps. Number 1. We will choose the scale. Let 1 centimeter represents 5 Newton. Number 2. Measure the length of the vector r. From figure it is about 4.8 centimeter. Number 3. Thus, according to the proposed scale, magnitude of the resultant is 24 Newton. Number 4. In order to find direction with the help of protractor, measure the angle r with x-axis from the scaled diagram, which is about 19.9 degree, approximately equal to 20 degree. Continuing the addition of vectors, now we have commutative property of vector addition. Consider the two vectors a and b. Let these two vectors represent two adjacent sides of a parallelogram. Now first we construct the parallelogram by placing vector b onto the head of vector a, or by placing vector a onto the head of vector b by head to tail rule. In both the cases, resultant will be r. So this is commutative property. We can write it as commutative property a vector A plus vector B can be written as equal to vector B plus vector A. This is equation number 2. The head to tail rule yields vector R for both A plus B and B plus A. Let's see the commutative property in case of 3 vectors. The order in which the given vectors are added has no significance. Let vector A, vector B and vector C are any 3 given vectors. Therefore, vector A plus vector B plus vector C is equal to resultant vector R. Or we can also write vector A plus vector C plus vector B is equal to the resultant vector R. Or we can also write vector C plus vector B plus vector A is equal to the resultant vector R. Or we can also write vector B plus vector A plus vector C, which is equal to the resultant vector R. In addition process, the vectors A, B and C which result R after addition are called components of R as shown in the figure. Such components of vector which makes an angle of 90 degree with each other are called rectangular components. Now students, this is assignment day 1 from vectors and equilibrium. Thank you students.